So myself is Jamin Sangani. Uh, I have completed my BE, Master of Engineering, and now I am doing the PhD, pursuing the PhD in the area of wireless communication. Today we will discuss the concept related to number conversion system according to the part of subject digital electronics digital electronics. So, so in digital electronics, for this particular lecture, we will discuss the concept. We will discuss the concept related to the octal to binary code conversion. Related to the octal to binary code conversion. First of all, how octal number that can be represent how octal numbers that can be represented that I will discuss, and after that how octal to binary conversion and binary number to octal conversion, how it is possible, that I will discuss, that I will be discussed later on. So first of all, what is the meaning of octal number? What is the meaning of octal number that I will be discussed. Now see, now see here, right, octal number system. Here write octal number system. What is the fundamental concept in the octal number system? First of all, first is the fundamental features that can be present in the octal number system. It is known as base, or it is considered as a base. So now base used for octal number system, base used for octal number system is 8. Now second, the number of value assumed by each digit, number of values number of values assumed by each digit, number of values is assumed by each digit. Each digit in the octal system will assume 8 different values starting from 0 to 7. In octal number system, octal number system, octal number system, each digit will assume 8 different values. Each digit assume 8 different values. What is the starting point of this value? starting from starting from 0 to 7. Why? Because total 8 value is required. Value required. So here it is considered as a octal number system. Here it is considered as a octal number system, and largest value of digit largest value of digit in the octal system will be 7. Third point, largest value of system largest value of digit in octal number system is 7. Is 7. That means that means if value higher than 7, it will not be 8. It will not be 8. Instead of 8, instead of 8, that will be 10. Instead of 8, that will be 10. So here largest two digit in the octal number, largest two digit, this is most important for the MCQ. Largest, I write with the help of black marker. Largest two digit octal number is 77. Largest two digit octal number is 77. Now I will discuss this concept in the Gujarati language. So better you have to understand, or you will understand. Suppose in octal number system maximum value 0 થી 7 સુધીની જશે. 8 value નહીં હોય, 8 9, કારણ કે octal itself indicate maximum value is 8. So starting from 0, so 0 to 7, starting from 0, it is considered as a 0 to 7 value. 0 to 7. So maximum value in the octal digit is 77, and after the 77, what is the next value? It is known as 100. After the 77, what is the next value, which is known as 100? So I will sketch the table. See this. Now I will mention here 0, 1, 2, 3, 4, 5, 6, and here I will write 7. Now 10, 11, 12, 13, 14, 15, 16, 17. Next 20, 21, 22, 24, 25, 26, 27, 30, 31, 32, 33, 34, 35, 36, 37, 40, 41, 42, 43, 44, 45, 46, 47, 50, 51, 52, 53, 54, 55, 56, 57. See this. This is the largest value of a digit. See, this is the largest value of digit. Here. Now, next point 70, 71, 72, 73, 74, 75, 76, 77. See this. This is the large value. This is the large value that can be present in the digit. Now see octal number. Octal number minimum value 0 to 7. Minimum value 0. Maximum 7. So we say that this is the largest value in the two digit. That's why 80, 81, 82 means what? 77 to 99 value not possible. See this. I will write that point here. So 78 to, see here, I have write here 78. 78 to 99 two-digit value is not possible in octal number system. Is not possible in the octal number system due to octal number vary between 0 to 7. Octal number that can be varied between 0 to 7. Octal number that can be varied between 0 to 7. And largest number in the octal digit is 77. Largest number in the octal digit is 77. So now we will concentrate on the next point. How third three-digit data that can be write. See here, 100 is the minimum value in the octal number to represent 3-bit octal number. 104, 105, 106, 107. See this. This is the three-digit data that write in this way. Here 111, 112. It is the 3-bit digital data. See this 3-bit digital data write in that particular way. So now how to weight given in the different position for an octal number system. 78 થી 99 વેલ્યુ શું કામ નહીં આવે? 78 થી 99 વેલ્યુ શું કામ નહીં આવે? કારણ કે 0 થી 7 સુધી જ octal number હંમેશા ચેન્જ થાય છે. That's why 78, from 78 to 99, it is not possible to get the value. It is not possible to get the value. That's why. That's why starting range of the octal number in the 3-digit is 100. Is 100. And uh, what is the lowest range in the 2-bit data? It is 11. For single bit, it is vary from 0 to 7. So now we will switch over the next point, which is known as weights given for different position in the octal number system. Weights given weights given for different position in octal number system. So now how weights that can be given? See this. Here. Now see. Now see this. Suppose assume that this is the point number. So here it is assume 8 raised to 0 multiply. Here assume 8 raised to 1. Here assume any data that can be multiplied with 8 raised to 2. So it can be representation. Here 8 raised to minus 1. Here 8 raised to minus 2. So here it is known as most significant bit. Here it is known as least significant bit. I write here MSB, most significant bit, and LSB, least significant bit. So now each digit has multiple base that we show in the figure. So now next point that can be considered as a application of the octal system. Next point that can be considered as a application of the octal number system. Application of octal number system. First application, first application of the octal number system. In order to represent large number, in order to represent in order to represent large number at that time, in binary digit, large number of 1 and 0 is required. So in octal system, less data represent very clearly. Less data that can be represent clearly. Second, so octal number that can be used to represent less data, already discussed. Octal number system, it is just used for convincing the user to represent less amount of data for user purpose at that time. At that time, octal number can be used. Octal number that can be used. So it is the application of octal number. It is the application of the octal number. Now, now octal number, how it is converted into binary, octal to binary system conversion, or we can say octal to binary conversion, how it is possible. See this. First of all, we discuss the octal to decimal conversion. First of all, we discuss the octal to decimal number conversion, and vice versa also learn decimal to octal conversion. So first of all, octal number, how it is convert the octal number, how it is convert the given octal number into decimal. How to convert the given octal number into decimal. So first example, octal to decimal conversion, octal to decimal conversion. First example, first example, 314 represent in the decimal that can be converted into octal. How it is possible? So see this is the zeroth power. So 8 into 8 raised to 0 into 4 plus 8 raised to 1 into 1 plus 8 raised to 2 into 3. So here 4 plus 8 plus 48, sorry, 64 multiplied by 3, 64 multiplied by 3, so 12, 192, 192. So here 192 plus 8 plus 4 is equal to 204. See this is the zeroth power, this is the 1th power. How it is converted into the octal. 204 that can be represent, sorry, 304 that can be represent in the decimal. Here convert 304 into octal. Sorry, by mistake. And here it is converted into decimal. Just like as a decimal to binary conversion, but in binary if this data that can be represented in terms of binary, then you have at that time you have do here 2 raised to 0 multiply by whatever data, 2 raised to 1, 2 raised to 2, like that. But here data can be represented in the octal. That's why multiply with the 8 raised to 0, 8 raised to 1, 8 raised to 2 based on the power. See, this is the lower position, this is the medium position, this is the highest position. Now second example. See this 675 octal number converted into decimal. So here 675 octal, 8 raised to 0 into 5, 8 raised to 1 into 7, 8 raised to 2 into 6. So here 5 plus 56 plus 64 into 6. 64 into 6, 384. 384 plus 56 plus 5. So is equal to 445 that can be converted into decimal. So octal to decimal conversion that is possible. So see this step very carefully. See this step very carefully. Now see next example. Now see the next example. If any data that can be given into the any form, like octal number, binary number, hexadecimal number, third power number, any number that we will that you want to convert it into decimal, at that time multiply with base. Just fundamental concept. Just see that fundamental concept. See third example. In third example, I have put data like that, 15 power, 15 base, that we would like to convert it into decimal. At that time, consider this is the lower value, this is the upper value. So 15 raised to 0 multiplied by 5 plus 15 raised to 1 multiplied by 8. So here 15 raised to 5 means 1. So 5 plus 15, 8s are 120. So it converts it into decimal number 125. કોઈ પણ બેઝ હોય તમારે ડેસિમલમાં કન્વર્ટ કરવું હોય એટલે એ બેઝને એના એકમ દશક 100 વડે ગુણી નાખવાનું, બીજું કાંઈ કરવાનું નથી અકોર્ડિંગ ટુ ગુજરાતી લેંગ્વેજ. તમારે લોકોને આ જોવો અહીંયા ચોથો એક્ઝામ્પલ હવે ગુજરાતીમાં ગણાવું છું. 859 octal number. See this. Now this is the most tricky example. આ tricky example છે. આનો આન્સર શું આવશે? This type of octal number, આ ટાઈપનો octal number possible નથી. This type of octal number is practically not possible. Is practically not possible. So not possible to convert. Possible to convert octal to decimal directly. Directly it is not possible to convert octal into decimal. Why? Because in octal maximum range is 0 to 7. Minimum range is 0, maximum range is 7. Now consider the next point, fifth. 7 to 6 octal number that can be required to convert into decimal. That's why 8 raised to 0 into 6, 8 raised to 1 into 2, 8 raised to 2 into 7. See this. In this particular way, you solve the example. So 6 plus 16 plus 64 multiplied by 7. 64 multiplied by 7. So 448. 6 plus 4, 16 plus 448. So 470 is the last answer. 470 is the last answer to convert the value into the decimal. So now next example. 706.621. Convert the given octal number into the decimal. Convert the given octal number. See, this is the answer. I write the answer actually. See, this is the answer. This is answer here. Please carefully note down that point. Here also it is known as answer. See this type of example that we discuss here. So now we like to find this particular answer. Now see, it is considered as a 8 raised to 0 multiplied by 6 plus, consider this value, 8 raised to 1 multiplied by 0 plus 8 raised to 2 multiplied by 7. અહીંયા 0 1 2 શું કામ આવ્યું તો કે એકમ દશક 100 અકોર્ડિંગ ટુ ગુજરાતી લેંગ્વેજ, unit part, ones part, hundred part according to English. So here we say like that, and here see this. Now this is new for you. 6 into 8 raised to minus 1, 8 raised to 0, sorry, plus 2 into 8 raised to minus 1 plus 1 into 8 raised to minus 2. Here power can be increasing from right to left, but here power can be decreased from left to right. Simply say according to the fundamental of line number, if you can move towards left side, then power can be decreased, -1 -2 -3 like that. But if you can move from left to right, at that time power is increased. So similar for that, if you can move from that, at that time power can be decreased as z raised to -1, z raised to -2 like that. Clear that point? શું કામ તો કે નંબર ડેસિમલ નંબરના કન્સેપ્ટ પ્રમાણે પાવર ડિક્રીઝ થશે. એટલે અહીંયા શું આવશે તો કે 8 રેઝ ટુ 0 ઇન્ટુ એટલે 6 પ્લસ 0 પ્લસ 64 multiplied by 7, 64 multiplied by 7, 448 point 6 plus 2 divided by 8, 0.25 plus 8 raised to minus 2 means what? 1 upon 64. So 1 divided by 64, 0.015625. So 0.015625 plus 0.25 plus 6, 0.626, 0.626. So here point 626. One silly mistake there. See this. Here 6 raised to 6 into 8 raised to minus 1. Here right, so minus 2. Here right, minus 3. So now 6 divided by 8. 6 divided by 8, 0.75. See this. 0.75. Here 2 divided by 64, 2 divided by 64, 0.0315, 3125 plus 1 divided by 512, 1 divided by 512, 1 divided by 512. So here 0.001953 plus 0.03125 plus 0.75. So get the answer 0.7830320, 0.78320, 448 plus 5, 554. So 554.78320.3125, that is converted into decimal. That number that can be converted into decimal, which is given in the 6 to 1. See this. This is the clear representation of the answer. This is the clear representation of the answer to convert the octal number into decimal. Now reverse process. How it is possible to convert the decimal number into octal? Again repeat, how it is possible to convert the given given decimal number into octal? Here we have already completed, I have already completed how the octal number that can be converted into decimal. How octal number that can be converted into decimal. So octal to decimal conversion. Now next point, which is known as decimal to octal conversion. Decimal to octal conversion, reverse process. Here it can be multiply with each other. So now we will discuss how the given number. See this first example. We will solve the 4 to 5 example. How it is possible to converting octal. Decimal માંથી octal number માં જવા માટે શું કરવું? See this. See this point very carefully. So here we solve the 5 to 6 example related to that point. Now answer of first question. See, here we would like to convert the given decimal number into octal. That's why in previous step we divide the value, sorry, multiply value. Now we divide with 8. Whatever base we want to convert it, based on that we have divided. We divide all the value. See this 8 2s are 16, remainder is 4, 8 5s are 40, remainder is 4. So what is the entire remainder? And here 8 that can be multiplied, 8 that can be divided with 4, it is not possible. So here it is converted into octal. It is known as LSB, it is known as MSB. Most significant bit, least significant bit. Divide, just divide, and whatever remainder that can be present. See this. 8 divided with 204. 8 2s are 16. Remainder 4. Here 4 as it is. 8 5s are 40. Remainder is 4. This is known as quotient. This is known as quotient. The quotient that can be right here. Remainder that can be right here. So here 8 that can be divided with 4. It is not practically possible. It is not practically possible. So here whatever term we get here, it is known as LSB. LSB means what? Least significant bit. Here it is known as most significant bit. So it is the completion of first example. See this. This is the answer. See this. This is the answer. Now next, second question. 364 decimal. How it is possible to convert into octal? 364 decimal. Sorry, another silly mistake that can be done. If you can divide 8 with 25, then here 4 is correct. But here, if 8 that can be divided with 25, then 8 3s are 24, remainder is 1, and 8 that can be divided with 3, then answer is 3. So 314. 314 is the final answer. 314 is the final answer. It is known as least significant bit. It is known as most significant bit. Another important point, see here, is also known as is also known as most significant bit. It is least significant bit. That's why answer is 314. That's why answer is 314. That can be converted. Now 364 decimal number. How it is possible to convert into octal? So 364 8. 8 3s are 24. 8 4s are 32. So remainder is 4. And this 4 and 4, 44. 8 5s are 40. So remainder is 4. Now 8 5s are 40. Remainder is 5. 8 0. Remainder is 5. It is known as most significant bit. It is known as least significant bit. So 554, it is the octal number conversion. Now third example, 567. Third example, 567, that is the decimal number. How it is possible to convert into octal? See, this is the answer. Here 567, 8 sevens are 56, and 8 0. So remainder is 7. Now 8 sevens are 56. 8 eights are 64. 8 that can be divided with 70. So 8 eights are 76. 8 eights are 64. Remainder is 6. Now this 8 can be divided with 8. 8 ones are 8. Remainder is 0. And 8 that can be divided with 0. So answer is 1. It is known as most significant bit. It is known as least significant bit. So answer that can be right here 1067. So here 1067, that can be converted into octal. Here, so it is converted into octal. Now next example, fourth example, it is very similar to compared to first, second and third. Now see fifth example. So you will try to solve by yourself. Fifth example, 658.23. Fifth example, fifth example, 658.23. This decimal number that can be required to convert into octal. So here 8. 8 eights are 64. 8 eights are 64. 8 twos are 16. So remainder is 2. 8 ones are 8. 8 0. So remainder is again 2. 8 ones are 8. Like that. 8 ones are 8. Here it is known as remainder. Remainder is 2. Now 8 that cannot be possible to divide with 0. So here 1. So here it is known as MSB, most significant bit. Here it is known as LSB. So answer is 1222. Answer is 1222. That is converted into the decimal. That is converted into the octal number. But still here 0.23 is present. So 0.23 that can be multiplied with base, that can be multiplied with base. Here we consider decimal fraction. Here we consider decimal fraction that can be multiplied with base. See, base is 8. So what is the multiplication of 0.23 multiplied by 8? 0.23 multiplied by 8. So answer is 1.84. Answer is 1.84. So here 1 that can be considered as a MSB, most significant bit. Now next, why? Because power of point that can be degraded. Here at 8 raised to minus 1, 8 raised to minus 3, 8 raised to minus 4, we have already studied that. That's why it is known as MSB, which is known as most significant bit. See this. Now 0.84 that can be multiplied with 8. 0.84 that can be multiplied with 8. So here 0.84 multiply with 8, so 6.72. See this, here 6. So now 0.72 multiply with 8, 5.76. So now it is known as 5. So next point, 0.76 into 8. 0.76 into 8, 6.08. So 6. So here 0.08 multiplied by 8, 0.64, 0. So here we get this type of MSB, this type of LSB. You can do up to 4 steps, 4 to 5. So here, what is the final answer? See this. This is for integer value. This is for fraction value. So what is the final answer? Final answer is that 1222.16560. 16560. It is the answer that can be converted into decimal. Sorry, it can be converted into octal. Sorry, it is converted into octal. See this, octal. So it is conversion that can be related to the decimal to octal. Conversion that can be related to decimal to octal. See this. This is the answer. So how integer value and fraction value that can be related, that I have explained here. Another last example, 6. 6 and last example, See this. What is the data? 627.124. 627.124 decimal number, how it is converted into octal. So see this, whatever base that can be given here, it is known as 8. So what is the answer? What is the answer? See here, consider integer part. 6 to 7. See this. How 6 to 7 that can be converted into octal. 8 sevens are 56. So remainder is 6. 67. 8 eights are 64. So remainder is 3. Now again 8 sevens are 64. 8 sevens are 56. See this. 6 to 7. 8 sevens are 56. Remainder is 6. 67. 8 eights are 64. Remainder is 3. Similar way, similar kind of way, આ જ રીતે 78 ને ડિવાઇડ કરો. 8 nines are 72. 8 nines are 72. Remainder is 5. See this. Remainder is 5. 8 ones are 8. Sorry. Remainder is 6. Sorry. Remainder is 6. Remainder is 6. Clear? 8 ones are 8 divided with 9. 8 ones are 8. Remainder is 1. Now 8 divided with 1. Remainder is 0. So it is known as integer part. It is known as integer part. How it is converted into the octal number. This is known as MSB. This is known as LSB 1163. Now 0.124 that can be converted 0.124 that can be converted into octal. How it is possible? 0.124 multiplied by 8. See, this is the decimal fraction, this is the base. 0.124 divided by 8 multiply with 8, sorry. So here 0.992. So whatever 0 that can be present, it is known as MSB, most significant bit. So it is known as 0. Now 0.992 multiply with 8, 7.936. So here another which is known as 7. So now 0.936 multiply with 8, 7.488. So here 7. Consider this only. Other term that can be goes here. 0.488 multiply 8. 3.904. So here we get 3. So here term that can be goes like that. 1163 0.773, it is the answer that can be converted into octal. See this. So here octal to decimal conversion and octal to decimal and decimal to octal conversion and importance of octal conversion we discuss we have discussed in this class. Okay, thank you very much. Okay, thank you very much.